Today I'm going to talk about how to abuse Azure AD password authentication vulnerabilities we found earlier this year. So I'm going to do a lot of demos. So a couple of slides then to the demos. And they are live demos, so let's see how it goes. It's always nice to, try to tease demo cards. Okay, so I got already introduced, so it's me, Nestori. Hi, I'm from Finland. I work for Secureworks, and you can, follow me on Twitter and also in Mastodon, because that's what we do nowadays. I'm a Microsoft MVP, and I'm also Microsoft MBR, which stands for Microsoft Most Valuable Researcher. So every year in Black Hat, US, Microsoft Security Response Center is publishing a list of 100 most valuable researchers, and I was second year on that list, and this time I was on 17th place. So it's nice to be there. Okay, so most of the people around the world know me from my toolkit, AD internals. Anybody use that here? Okay, couple of, yes, okay. Well, I have some stickers here, so you can, just pick me from my leave later on, and I will give you stickers if you want to. So it's an open source tool, and I'm going to use that today also. It's been listed by MITRE ATT&CK since February this year as a software S677, and it has been used by groups like APT29, also known as Nobilium. And as we track that in Secureworks, it's called IRO Ritual, but the same organization. But they haven't paid me anything, any ransomware they got from this, so yeah. And today's talk, it's based on three, let's say, documents, if you will. So 2 blog posts of me, and then Secureworks threat analysis we published on, I think that was in September, yes. So today I'm going to cover 3 things, not necessarily in this order, but anyways, I'm going to tell you what is password authentication, how we can abuse that, and also how to detect the abuse and how to mitigate if possible. And let's start with talking about cloud security. So I got this question quite many times, that is cloud secure? And I would say that yes, cloud is secure as such. So it's easy for users, they just need to provide some form of proof of identity, and they are able to use their services. And it's bad for attackers or threat actors, because they can't use their old methods to penetrate on-prem. They can't do that anymore. So yeah. If you're using only cloud, it's okay. But most of the organizations are not cloud only. They are so-called hybrid, which means that they are using same identities in your on-prem and then also in cloud. And that's good for admins, because it's easier to manage. You have only one set of management tools. And it's good for users because you can use same credentials in on-prem and in cloud. And it's extremely good for attackers or threat actors. And why? Because when you are doing this hybrid, you're actually connecting your on-prem to cloud, and you are poking holes to that safe cloud environment. And guess what? Attackers can now attack your on-prem. And via on-prem, they can get into your cloud. So that's what happened during the SolarGate attacks, for instance. And there are plenty of options you can choose that which authentication option you are using. And today we are going to talk about the PTAs. And talking about PTA, let's go to the high-level architecture, so how it works. So here it is. So basically what happens is that when users are trying to log in an organization that is using PTA, it is like typing the credentials, username and password in cloud. Okay? And then Azure AD is sending those credentials to agents that are installed in your on-prem environment. So they need to be installed on servers that are domain joined, which are right here, as we can see. And those credentials are encrypted. And the agent is decrypting them. And then technically, the third part here is, it is sending those credentials to System32 function called logonuserW. So basically, it's trying to log in as that user. And that's when the agent is actually connecting to on-prem AD. And then it will return the results. So that's the high-level architecture. But now let's go into details. So this is what happens when the PTA agent is starting up. And as you can see here on the top left, there's a certificate, which means that PTA agents are using certificates as an authentication method. So they are using certificate-based authentication, or CBA. And it is connecting to the Azure AD, and the first thing it wants to get is a configuration, and that is called bootstrap. And that's what happens with the steps 1 to 4. So basically, it starts by connecting to Azure AD, and it's telling Azure AD that, hey, give me the configuration. And when it gets the configuration, it is establishing WebSocket connections to Azure service bus. So it usually has like 8 different connection points, endpoint it is connecting to. So this happens what you start up the agent. And now the agent is ready to, for receiving the authentication request. And now what happens technically when you authenticate, it is like this. So everything starts with service bus, where Azure AD is sending you the credentials, the user type when he or she logged in, right? And then it says that actually first that, hey, connect to this relay. And then the agent connects to relay, and then via relay, you will get the authentication request. And then on step 4, the agent is sending those authentication response to a proxy. So there's a lot of components here. So it's very messy, but it's quite robust actually. It's working all right. Now, what is inside that authentication request then? So that's important. So actually, I think I forgot to mention that Microsoft says that you should have at least 3 agents for high availability, and a maximum number is like 40. So technically, you can't add more than 40 agents. And in authentication request, you have the user's username and password, and the password is like encrypted. And it has entry for all agents here. So every agent usually gets the list of, the authentication request, and it has entries for each of those agents. And usually there's only one certificate per agent, but there can be more than one, usually if you are compromised, but there are certain situations where that's normal for a short period of time. But anyways, based on this information like a key identifier, so that's the agent ID and then the thumbprint of the certificate. So those help the agent recognize which like encrypted block I should be decrypting. So yeah, we will get back to this later. And now, how to abuse PTA? Now that we know some technical backgrounds, and I only have like 30 minutes, so I need to move forward quite fast. So to the abusing. So I've been doing this PTA abusing since 2019 at least. So that was when I published a thing called PTA Spy. And to use that, it requires that you will get the local admin level access to that server that is running PTA agent. So you don't need to be like domain admin or anything like that. Local admin is just fine. And what you do there is that you actually inject a DLL to the PTA agent process. And what that technically does is that it replaces the local user W system function in that process, not in the whole computer, but in that process. And it accepts all the passwords. So it doesn't communicate with AD anymore. It's just accepting every password you give them. And it also saves all the credentials to the local CSV file. And I heard that APT29 has been using this actual PTA Spy for, gathering credentials, but also like as a backdoor, because it accepts every password you are able to log in as a user you want to, right? But this is a bit noisy. When you are injecting something in processes in Windows, it's, every EDR solution nowadays will, notice that and block that or whatever they are doing. So we invented another way. So this is based on our research this year. So we can now steal the identity of the PTA agent. So we don't have to be on the server anymore. We can be the server. And this also requires only local admin permissions on the target server. So what we do here, we just, get the certificate which the PTA agent is using for CBA and also for decrypting those credentials. And we put it on the threat actor control computer, and now we can impersonate that agent without any connection to the on-prem anymore. And you want to see some demos? Okay, so let's do that, and I'm going to change the mic now. Okay, yes. Nice. So let's see how this works. Okay. I found my mouse, great. And I'm pretty much in time, so this might be a bit funny because I don't know how this actually works because let me try something else. It's a bit far away to see there, so let's try something totally different. Now that's better. Okay. So what do we have here? So we have two, let's say, target organization servers. So we have a domain controller that has PTA agent running. It's a bit small here, but it's this right there. And then we have the server that only has PTA, and it also has the agent running right there. Okay. And then we have the attacker machine. And let's start by running the PTA spy. But first I'm going to shut down the... no, I'm not going to do that yet. Sorry about that. I was going ahead of my time. So let's open up an admin portal of the organization. So what an admin can see about those PTA agents, so we are now running two of them, and here's the admin portal, which shows us that, okay, we have two agents, we know their names and the IP addresses, and that they are active. And that's the only information you can get as an admin from the portal. However, there are some API endpoints that you can use to request the same information, and I'm also implemented this in AAD internal, so I'm going to say get AAD int, what is that called? Proxy agents, and format table. And here we can see, in a second, okay, so now we can see the same information here, but we can also see what is the ID of the agent. And that is important, because that kind of, well, it identifies the agent. So now a part of detection stuff. So again, when I go back to portal here, and I'm going to go to sign-in logs. Like right here, okay. Okay, two fast fingers. Let's go back and sign-in logs. So we can see sign-in events here. And I'm going to try to find out the correct one. I would like you to see. There's too many of these. Okay, so failure, success. Let's try that one. And when we go to authentication details, we see that, well, it's very small. So when I, hover my mouse there, it says that this was password authentication and the agent ID here is 3E something. So you can see actually that which agent performed this, the login. So if they are like some weird behavior that, okay, this certain agent is like accepting everything or blocking everything, you know that, okay, maybe that's compromised. But anyways, I'm actually going to start a script here that is showing this same status here every 3 seconds. Okay, and now I go to DC, and I'm going to shut down this particular agent so that we can be sure that the PTA server is going to get all the requests. And I'm going to start the PowerShell here. And as we can see, I created a new version. DefCamp edition just for this conference. And what I'm going to do now is that I'm going to install AAD in PDSpy. Are you sure about that? Yes. And it's completed, and I'm going to open the process hacker. I'm going to search for Azure. I'm going to zoom in. So not yet. So it's this one. And I'm going to zoom in a bit so I can see that the PTA spy is actually injected in that process. Okay? So now it's accepting all the passwords and saving everything to a file. And now I'm going to try to sign in as this user. And what password should we try? Okay. Hello, DefCamp. And it doesn't actually matter what I type here because it accepts everything. And I'm just going to, no, that one. I need to log out. I don't want to say my password. Okay, sign out. And when I go back to this computer now, I can say get AAD int. Okay, can type. PTA spy lock. And provide decrypt or decode passwords. And now it shows the password, so hello DefCamp here. And it shows when it happens and so on. But anyways, as I told you, this is a bit like noisy. It's easy to get caught. So let's do the stealing the identity stuff now. Just going to close this one. And I have another session here. It's red because that I recognize that. Because when I run this command to export the certificates, this session gets elevated to local system, which means that you can't use that to anything after that. So I'm just going to say export AAD int proxy agent certificates. And it's exporting the everything. And as we can see, there's two different certificates. And I happen to know that the one that starts with 308 is the correct one. Okay, now what I'm going to do is that I'm going to shut down the agent also here, like this, and then I go to attacker machine, where I have already copied that certificate. And when we were researching this, we actually implemented our own, let's say, proof of concept of agent, and I'm going to show you how that works. So I'm going to run PTA agent. It's on very small, sorry about that. And I'm going to provide the certificate, which we have here. It's a DefCamp. So it's that one. And also I need to provide the name for the machine. And I say, okay, hacked. And let's see what happens. It should work, but we don't know. Because that's a proof of concept. So it is. So it was actually now connecting to those endpoints I was mentioned earlier. So these are in the configuration file. And now when you are looking at the bottom of the screen, the name and the IP address should now change. And why that happens is that we discovered that IP address is changed whenever the agent is getting the configuration. And when it's getting the configuration, it's also sending the machine name. So it should like change here in, okay, now we can see. So it's hacked and the IP address changed. So you are get caught, okay? This obviously works, so if I go here and try to sign in, well, hopefully it works. I just type something here, and we should see some traffic here. And let's see. Again, because it's a proof of concept, it's not that stable, so it didn't work this time. So we're just gonna start again. And let's try again. And it should show us the password in just a couple of seconds, but again, it depends. So this is nice to have these, live demos, but I'm going to do that one more time. We have time for that. Also, also the network connection might be one of the reasons, but let's just try A. But we see the, yeah, but there's like a, no, it doesn't want to work now. But let's see if it works after a couple of seconds or minutes, maybe, maybe not. But anyways, the point it was here that you will get caught because the name and IP address changes, right? But we discovered that if you like provide the configuration to the agent so that it doesn't need to get that, so it is connecting to directly those endpoints, the IP address and the name doesn't change. So where was I? So now I go back to the PTA server. I'm going to start the agent so it will get the configuration and change the IP back to the original. And I think, blah, blah, bum, 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 I think it's done already. So I can stop that. So it should change back. But now I'm going to run the same PTA agent here, but now this time I'm going to provide the bootstrap. And now you can see the name changed back to original. And now when I provide the bootstrap, it is connecting there now, but because it's not getting the configuration from the server, those stays the same. So let's try to log in now, if that helped anything. Because now I'm running this from the local computer and it's connected to internet via my phone, so it might be not fast enough, so that might be the reason that it doesn't allow us to log in. But anyways, as we can see that the name didn't change, even though we connected there. So this is a way that if you are able, as an threat actor, you're able to get that certificate. It gives you like undetected access to the organization. And also, what I would like you to see is that if I provide a parameter called failure and enter any Windows like error code like here, it will work as a denial of service attack, because now anybody can log in. It says that your account is disabled. So I'm just try to run this one more time. And if it doesn't work, it doesn't work. So, but I can then demonstrate it later on. So let's try once again. No, it doesn't want to do that. But anyways, what the agent is doing now here, it would show the password of the user and then saying that your account is locked, so you can't log in to every user. And you don't know what the hell is happening. And what you can do actually is now you can go to see the sign-in logs, that if there is an agent ID that is like, having, like blocking all the users or accepting every user. And then you can do something about that. But what you can do as an admin, so now when I go back to the portal, and I see that, okay, this particular agent here is now compromised. So what can I do as an admin? There's no delete button here that I want to delete this agent, so you can't do anything. Well, actually, you can. So when you don't use that agent for 10 days, so it's inactive, it goes away automatically. But so you can uninstall your server and wait for 10 days, but that doesn't help. Why not? Because the threat actor is using your certificate. So it remains active until, well, forever. Well, it remains active as long as the certificate is valid. But guess what? You can renew that certificate using the old certificate. And you can do that again and again and again. So that means that now, and it also, this system allows that the one agent has more than one certificate. So we tried and it was something like 10. One agent can have 10 certificates. But you can't see it here. You can only see that, okay, there are agents active, but you don't know how many of those are compromised, or are they? So for that purpose, we in Secureworks, we actually created a tool that is called PTA Agent Dump, and that's a free tool, and we're going to publish it later this week, hopefully, which allows you to see that whether you are compromised or not. So I'm going to show how that works. So now I'm running this command on the PTA server, which you can do also. Just shut down the original agent. Then I'm going to run the tool here. So PTA agent dump. Oh, sorry, wrong place. And then I'm going to provide the certificate, which is under demo, and it's not that one, it's this one. And that's it. And now it also connects to, if we can see the connections here. We can't. That's nice. Let's try again. Okay, now we can see that it's connecting. And then you just need to sign in using any user, and also any password, it doesn't matter. Okay, well, it already did that, okay. So what it does is that it actually, if you remember the authentication request, so it can see that all the agent and the certificate pairs. So here we can see that it says that this particular agent has 2 active certifications. So now we know that threat actor has exported your certificate, and they have renewed that. So somewhere there's a threat actor that is, doing this stuff, and you can see that anywhere, except using our tool, which allows you to list those at least. But after that, the agent ID, you need to report to Microsoft that hey, remove this. So they can do that, but you can't do it by yourself. Okay. So I think that was all the demos I was going to show you. And takeaways from my talk. So first one, my personal opinion, don't use PTA. That's a piece of fine technology, but too fine currently, because you can't detect that, and you can't do any mitigations except for connecting Microsoft. And to protect yourself against these kind of attacks is the first thing that you need to treat any of those servers that are involved in hybrid identity as a tier 0 servers, which means that you need to protect them as well as you protect your domain controllers. And that's the first step. So this wouldn't happen at all. And then you can use MFA, which prevents using PTA as a backdoor, because that doesn't allow you to bypass backdoor. It only accepts all the passwords, and as we probably know, MFA is post-authentication, like a protection mechanism. So if you are using PTA, you are blocking that using as a backdoor. But you can still harvest credentials as a threat actor. You can't log in, but you can harvest credentials and maybe use them in other services. And then you should monitor those agents in regular basis, like are the IP addresses changing, and you can do that with A8 internals or by calling Microsoft APIs. And you should monitor those certificates using the PTA agent dump when we publish that, obviously. And then to follow any suspicious activity in signing logs. And finally, if you see that there's something suspicious going on with some PTA agent, you need to contact Microsoft to remove that. And with that and 20 seconds left in my schedule, thank you.
Thank you so much. Technically, we can take some questions, but we're going to eat out of your break. So if you want to ask questions, just, choose between that and going to the bathroom. So we can take 1 or 2 questions here.
Hello. Thanks for the presentation. I have a question. There was a recently an attack, well, it's not necessarily recently, but a Microsoft researcher who presented a NigoX relay attack. NigoX being the protocol that Azure AD uses that is similar to Kerberos, or it's based on the same API. And it's active on any machine that's joined to an Azure AD. And he demonstrated an attack that's similar to NTLM relay, but done on this new protocol, NigoX. Do you know if that still, is that related to this? Does that still work if PTA is disabled, or does PTA need to be enabled for that attack to work?
I have to say that that doesn't ring a bell, so I think that it's not related to PTA as such. Yes.
Okay.
But we can discuss about that offline.
Okay, sure. Thank you.
Thank you.
Are there any more questions? We can take maybe another question. If not, then thank you so much for your presentation. And in about 2 minutes, we'll start the next one.